She
Okay.
remembered it.
Now it is recording. I always forget this. Anyways,
Sorry, but can you upload our first tutorial as well? Because I don't see it on YouTube.
uh, I think I did. That was
There's
about probability, right?
no force derivatives test. The elasticity of demand part.
Okay, I check it. I check it. If I have that recording, I will upload it.
Okay.
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 So arithmetic mean or arithmetic mean is also called average, right? This is what we calculate in our daily life. But when we have extreme outlier like 100, in that case, we neglect that. Let's say we were having 2, 4, 6, and 100. So the right way to calculate its average, we will say since 100 is outlier, so we neglect or ignore 100 and we consider the rest of the numbers and calculate their average, which means that we will consider 2, 4, and 6. We will add them. We will divide them by 3. So the average is 4. Now you can see that this 4 is the true representation of these 3 numbers. This 4 is the true representation of these 3 numbers. So this is how we calculate arithmetic mean. Whenever we have extreme outlier, we simply ignore that outlier and we calculate the average. I give you one more example. Let's say you have a data 50, 100, 75, 80, and 2. In that case, this 2 is also extreme outlier since 2 is outlier. So we ignore 2 and calculate the average, which means that 50 plus 100, 75, and 80. So 1, 2, 3, 4 divided by 4, you can get the average. Is that clear? Is that clear?
Yes.
Okay.
Yeah.
So this is called arithmetic mean. Another one is called harmonic mean. When do we use harmonic mean? For example, uh, you have a data. Let's say I again consider this example 50, 100, or before this I consider the example we did before 2, 4, 6, and 100. 2, 4, 6, and 100. If you don't want to exclude the outlier, in that case we apply harmonic mean. And what do we do in case of harmonic mean? We say that this is x, 2, 4, 6, and 100. Then we take it as 1 by x, which means that 1 by 2, 1 by 4, 1 by 6, and 1 by 100. In statistics, when we add, we denote this. This is called sum. Sum of x. Uh, we are considering sum of 1 by x because this is 1 by x. So if you add it, it will be 1 by 2, 1 by 4, 1 by 6, and 1 by 100. So your sum of 1 over x would be, you can add it. If you add it, what will you get? I change my data. Let's say I make it 5 to make it simple. In that case, if I add them 100, 50, 25, 20, and 1, which means that 75, 96 by 100. So this is sum of 1 over x, and the formula for harmonic mean is, I write the formula for all the two. Formula for arithmetic mean is sum of x over number of observations, and we denote arithmetic mean with x bar, which means that x bar equals to sum of x over m. That is what we were doing. Coming back to your arithmetic mean, we had data 2, 4, 6. So what we do, we say that x is 2, 4, and 6. According to the formula, we need sum of x, which is 12. So arithmetic mean is sum of x over n. N is representing number of values. So 12 over 3 values, so average was 4. Similarly, for a harmonic mean, we denote it by HM, and its formula is sum of uh, n divided by sum of 1 over x. So the values are, in case of arithmetic, these were the values. So you can see that harmonic mean is equals to 96 by 100. Is that clear to everybody? Difference between arithmetic mean and harmonic mean is, in arithmetic mean, we remove outlier, but in harmonic mean, we include outlier. Now I give you one more note. What is that note? If 0 is included in our data, then to apply harmonic mean, we have to ignore 0 or we have to apply arithmetic mean. What does it mean? I explain this note. For example, I give you a data 0, 2, 3, 4, and let's say instead of 2 I make 6, and let's say again we make this data. Now here you cannot apply we cannot apply harmonic mean. Do you know why? Who can answer me why we cannot apply harmonic mean? Who can answer me?
Because 0 is included.
Very good. Because we cannot divide anything by 0. You
By
see,
0.
if we see the formula of harmonic mean, it is 0, 2, 5, 4, and 100. And according to harmonic mean, we need to convert it into 1 over x. So we cannot divide anything by 0. This factor is forcing us to not apply harmonic mean. So 1 by 2, 1 by 5, 1 by 4, 1 by 100, but this is undefined. So we cannot apply harmonic mean unless we ignore this 0. If we ignore this 0, if we ignore this 0 and we consider 2, 5, 4, and 100, then we can apply harmonic mean. Otherwise, you can see here, according to the note, if 0 is included in our data, then to apply harmonic mean, we have to ignore 0. We ignore 0. You can see here we have 0. Here we did not include 0. Or we have to apply arithmetic mean. So if we want to add 0, then apply arithmetic mean. But if we apply arithmetic mean in this data 0, 2, 5, 4, and 100, this is outlier. So we have to ignore 100 in that case if we apply arithmetic mean. So it will be 0, 2, 5, and 4. So sum of x is 11 and arithmetic mean will be 11 by 42.7 something. So this is how we calculate arithmetic mean. So I hope you can understand the difference between arithmetic mean and harmonic mean. When do we apply arithmetic mean and when do we apply harmonic mean? Next is geometric mean. Geometric mean is, for example, again you have data 2, 4, 6, 8. So the formula for geometric mean is x1, x2, x3 up till so on xn raised to power 1 by n. N means number of values. So if you have this data like 2468, it then says 2 times 4 times 8 times 6 times 1 by 4. So 64 times 6 raised to power 1 by 4. If you solve this, you can get geometric mean. So geometric, like arithmetic mean and harmonic mean, again, if 0 is included in the data, we cannot apply geometric mean. Can you tell me why we cannot apply geometric mean if 0 is included in the data?
Because it becomes 0 when you multiply.
Very good, because everything will be 0 if we multiply it with 0. Okay, so this is how we calculate geometric mean. Next is median. Median divide our data into two equal parts. First, we write the data in ascending order, then we divide it into two parts. For example, I wrote some random data 2, 4, 6. That was the random data I wrote before. Or I can take a new example. Let's say 0, 1, 3, 7, 2, 4, 6, right? So calculate median. Median means midpoint. First of all, we arrange the data in ascending order. The smallest number is 0. Then we have 1. Then we have 2, 3, 4, 6, and 7. So I wrote this data in ascending order. Now we divide it into two equal parts. There are 7 numbers in total. 3 would be on the left side, 3 would be on the right side. So our median is 3. Is that clear?
Yeah.
So median is 3. If we have, let's say, even number of values, 0, 2, 7, 4, 6, 9, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So when we have even number of values, again arrange them in ascending order. Arrange them in ascending order. So it will be 0, 2, 3, 4, 4, 6, 7, and 9, right? So since we have 8 number of values, so 3 would be on the left side, 3 would be on the right side, so we will left 2 middle values. So we will left 2 middle values, then calculate the average of middle 2 values, and that is, so your median will be 4 plus 4 divided by 2 is 4. So your median is 4. Understand? This is how we calculate median. Okay, next is mod. The most frequent value in the data is called mod. We can have more than one or two or three mods. For example, you have a data, let's say 0, 0, 3, 4, 5, 7, 3, 3, 4, 2, 1. In this data, which number is occurring maximum number of times? Like we have 0, we have 3, we have 4, we have 1,
0.
we have 5, we have 7. So this is our x. We write its frequency. How many times do we have 0? We have 0 2 times. We have 3 3 times. We have 4 2 times. We have 1 times. We have 5 1 times. We have 7 1 times. So maximum frequency is 3. 3 is occurring maximum number of times, and that is 3. So mod is 3. Understand? Understand?
Yeah.
Okay. So I change my example. If I remove this 3 from this example, in that case, we have 2 mods. 0 is occurring 2 times and 4 is occurring 2 times. 0 is occurring. Wait a second. What is she saying? We already had class today. In the afternoon. Right, Carolina, for fundamental mathematics?
Yeah,
Why is she asking me now?
I don't know.
Okay, anyways. So in that case, you can see we have 2 mods, like 0 is occurring 2 times and 4 is occurring 2 times. So in that case, so mod is 0 and 4. You can see here in the definition it says we can have more than 1 or 2 mods if 2 numbers are appearing maximum times but their frequency is same, so we will say that these 2 are mod. Understand?
Well, I didn't understand what What was the thing that you talked about? Frequency.
Frequency tells us how frequent a number is appearing, right? Next is quartiles. Quartiles divides our data into 4 equal parts. First, we arrange the data in ascending order. For example, I write a data, let's say 2, 4, 7, 8, 9, 10, 7, 6, 4, 3, 2, 1, 4, 7, 8, and 3, right? Is that clear? So first of all, we arrange the data in ascending order to calculate the quartiles. By the way, there are 3 quartiles. There are 3 quartiles, Q1, Q2, and Q3. If I arrange this data in ascending order, first of all, I will write 1, then 2, 2, 3, 4, 4, 4, there is no 5, there is 6, there is 7 2 times, there is 8, 8,
No, it's 7 3 times.
7, 7, yeah, 7 3 times.
There's 2 threes.
Huh?
2 3.
Yeah. 9 and 10. How many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's all. First of all, we calculate Q2. Q2 is equals to median. How do we calculate median? We divide the data into 2 equal parts. We have 16 numbers. 7 would be on the left side and 7 would be on the right side. So 1, 2, 3, 4, 5, 6, 7 on the left side and 7 on the right side. 1, 2, 3, 4, 5, 6, 7. And middle two numbers are 4 and 6. So we will calculate the average of these middle two numbers. 4 plus 6 divided by 2. So 5 is our quartile, which is Q2. Understand?
What is Q1 and Q2 mean?
Yeah, I come to that point. First, I calculate Q2. Is that clear? Is that clear how to calculate Q2?
Yeah.
Okay. Now we calculate Q1. Q1 is the median of left part. Q1 is the median of left part. What is left part? This is left part. This is left part. Understand? So if I calculate its median, how many numbers I have? 1, 2, 3, 4, 5, 6, 7. So 3 would be on the left side, 3 numbers on the left side, and 3 numbers on the right side. So this is my Q1. This is Q1. Is that clear? So
Yeah.
Q1 is 3. Understand? And Q3 is the median of right part. So right part again has 7 numbers. So we will split them, 3 on the left side, 3 on the right side. Understand? So this is our Q3, which is 8. So Q1 is 3, Q2 is 5, and Q3 is 8. This is how we calculate quartiles. And what is quartile? Quarter means we need to divide everything into 4 parts, and there must be Q4, but we always have Q3, because if I need to break this line into 4 parts, I can make one cut here, I can get Q1, I can make the second cut here, I can get Q2. If I cut 3, so I can get the fourth part automatically. This is the first part, this is the second, this is the third, and this is the fourth. I can get automatically the fourth one. So that is why we have only Q3. Actually, it divides the data into 4 equal parts, but we have only Q1, Q2, and Q3. This is how we calculate quartiles. Is that clear?
So there should be always only 3 numbers on the left and right.
3 numbers,
When
but
you,
3 numbers on the left and
no,
right.
I mean, whenever you're doing your like left side, there's a 3 number, and right side is the 3 number, and then you're trying to find the medium. But
No,
on
no,
the
no.
Q1, but I'm confused with this one.
It is not like,
Isn't it depending on?
let's say I write a different data. You give me random numbers, Sandra.
1,
Mm
5,
-hmm.
6, 8, 2,
Then
9,
-hmm. Then
9.
9.
Hello?
Yeah, give me some more numbers.
4.
4. Yes. Okay, we can stop it here. So now I
3.
okay, 3. I want to write it in ascending. First of all, we write it in ascending order. So 1, 2, 3, 4, 5, 6, 8, 9, and 9. Right?
Yeah.
I want to calculate its Q. First of all, we calculate Q2. Q2 is equals to median. Q2 is equals to median. How many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers. So 4 would be on the left side, 4 would be on the right side. So that is our median, which is also Q2. So
Yeah.
Q2 is 5, which is also median. Now we want to calculate its Q1. Q1 is median of the left part, right?
Yeah.
Left part is this one. So we have four numbers. How do we calculate the median in case of even? One would be on the left side, one would be on the right side. So we will take the average of middle two numbers. Average of middle two numbers, which are 3 and 2. So Q1 will be the average of middle two numbers, which is 2.5. Understand?
Yeah.
And now we calculate Q3. Q3 is the median of the right part. Again, we have four numbers. One will be on the left side, one would be on the right side. We will take the average of middle two numbers, 8 plus 9 over 2, which is 8.5. That is our
Okay.
Q3. Is that clear?
Yeah.
Okay. So this is how we calculate mean, median, mod, quartile. As we promised with Crystal and Carolina, we will not last it long. So in the tomorrow class, we will discuss some more things about mean, median, mod, quartiles, and also about ranges, variance, and standard deviations and things like that. Is that clear?
Yes.
Okay, if you have any question, you can ask. Otherwise, we can stop it here.
So for the final, it's gonna be this statistic stuff and also probability.
Yeah, this statistic stuff, probability, and also optimization, first derivative test and second derivative test.
Okay, perfect.
Will
Thank you,
we
sir.
have the elasticity of demand thing?
Yes. Christine, what were you saying?
Okay. Will we also have the elasticity part? The elasticity of demand.
I will look upon it, that how much stuff did we cover after the midterm. So everything, whatever we discussed after the midterm would be included.
Okay.
But we didn't have an assignment for the second test.
It is the
We
same thing.
didn't.
Whatever the assignment you had for the first derivative, you can apply the second derivative test on the same exam or same questions. I did mention this. I
Okay.
am saying it again. Whatever questions you had for first derivative test, you can apply second derivative test on the same problem for the first derivative test. Understand? Is that clear?
Yep.
Okay. Okay, then see you tomorrow. Tomorrow we have class, right?
Yes.
Yeah.
Yeah. Okay.
Yeah. See you tomorrow, sir. Have a nice night. Goodbye.
Bye-bye.
Bye.
Bye.
Thank you.
Welcome.